My name is Andrew Liu. I'm a program manager on the Azure Open Source Analytics and NoSQL team, and today I have...
Hi, I'm Raghav Mohan. I'm also a program manager on the Azure Open Source Analytics and NoSQL team.
And today, the two of us are going to give you a lap around Azure HDInsight and Cosmos DB. Specifically, what we'll do is we'll give you a nice overview of what each of these two services are, and then we're going to give you kind of an overview of some of the really cool things you can do in terms of solving big data problems at massive scale with both of these two services. So to start us off, let's talk about Azure Cosmos DB. What is this thing? In a nutshell, it's a globally distributed multimodal database service in which we have built an awesome platform that features global distribution, elastic scale-out, guaranteed low latency, 5 consistency models, and all of these fully backed by comprehensive SLAs. This platform is completely multi-model, meaning it can support key value, column family, document, and graph data models. And then these get exposed through a variety of APIs, including a tables API, a document DB API, MongoDB API, and Gremlin.
So Andrew, this is very powerful. This means that I can write my application in SQL, MongoDB, Gremlin, and you still provide the same SLA and the benefits as the underlying Cosmos DB engine does.
That's correct.
And you have more services that you're going to add too from a language perspective?
Yep, and so over time what you'll see is additional API services based off of popular open source databases appear on top of this platform. And in each of these we'll be able to take advantage of the fully managed
Cosmos DB platform.
The platform,
wow.
Yes.
Very cool.
So a lot of people ask me, like, what is global distribution? And one way of thinking of this is the ability to distribute your data in multiple regions and data centers around the world. Now, this actually goes a step beyond what most people think about in terms of replication. Typically, when you think about geo-replication, you're thinking about adding an additional region for business continuity and disaster recovery. So if, let's say, an earthquake or a major disaster happens in one region, you can automatically fail over to another region. Cosmos DB actually takes this one step further, in which if you have a global user base, let's say you have users from North America to Europe to Asia, we can actually solve the speed of light problem. And the speed of light problem is that shipping a packet across continents or around the world typically takes 100 millisecond latency or a couple hundred millisecond latency. Now, if you want to actually give very low latency access to your data, let's say single-digit millisecond latencies, the way we cheat the speed of light is we actually exploit data locality and replicate your data into each one of these regions. And then these get all stuffed behind a single multi-homing API so that you have a single convenient endpoint that a client can then configure what are their preferred regions and do policy-driven failovers. And you can do these failovers both in a manual or automatic fashion.
That's very cool, Andrew. So how many regions is Cosmos DB currently present in today?
So Cosmos DB is a foundational service within Azure, meaning that we have a lot of our internal Azure services as well as properties around Microsoft making a heavy bet on this. And as a result, we must be in every Azure region, and today we're in 30 plus regions, and this will continue to grow as Azure adds more regions.
So Cosmos DB is a Ring 0 service within Azure?
That is correct.
Very cool.
So now that you have your data globally distributed, what you also want to do is be able to scale out that data in terms of a couple of dimensions. And typically you want to think about this in 2 dimensions, storage and throughput. Storage is how much data you have stored within that database, and throughput is how many requests per second, whether that's reads or writes, coming through. Now, because this is a fully scale out system and partition management is automatically taken care of for you, you can conveniently just dial a knob, and whether you need, let's say today, hundreds of requests per second to tomorrow hundreds of millions of requests per second, it's just a one button click away, and we'll take care of all of the work behind the scenes to make sure that we scale out enough hardware underneath.
So as a user, if I'm writing my application and then I I see that Black Friday is here today, and I need to scale this up. How easy is it for me to scale this out today? Is it just like you say, click a button to the portal, and this happens within seconds? How does that happen from a user case?
So we actually allow you to scale on demand and maintain high availability during this scaling. And we give you a variety of mechanisms for doing this. One is through the portal, and the other is through programmatic access. So in this manner, if you know that, let's say you have traffic, peak traffic from 9 to 5, you can actually write a scheduled job that automatically scales the database up from the hours of 9 to 5, and then scale it back down on quiet hours.
Very cool.
So now that you have a bunch of requests coming in, your data is in the database, let's talk about performance. And in particular, let's talk about what kind of performance guarantees you get with this database. Now, lots of databases like to tell you that they're performant in the best case scenario, and they'll give you a performance benchmark. Cosmos DB takes that one step further, in which we actually are the very first cloud service to offer an SLA on latency, in which if we benchmark on a typical 1 kilobyte record, you will see reads, typically around point reads, P50 at less than 2 milliseconds and P99 less than 10 milliseconds. What that means for you is we put the SLA on P99, so you get performance not just in the best case scenario, but you actually get predictable performance so that you can bet mission critical workloads on this. This is made possible by the fact that we have a write-optimized latch-free database, so we can also give you very, very high performance and low latency on the write path, in which we will automatically index those writes as they come in without any locking mechanism, so you can get very high throughput.
Very cool. So, Andrew, how does throughput affect SLA? Like, if I scale my cluster up, do I have to pay a penalty on the SLAs that you provide for the P99 reads and the index writes?
And this is a really cool thing about a scale-out architecture, is what we do is we actually operate on many, many smaller partitions, and we can keep adding these with minimal overhead. As a result, as your data volume grows, as your throughput grows, as your storage grows, you actually get the same awesome performance guarantees no matter how large your scale is. Now, whenever you talk about replication and distribution, one of the really critical things to understand is consistency. Most commonly, people understand this in terms of Brewer's CAP theorem, which talks about the trade-offs between consistency and availability in the event of a partition. You can actually take this one step further, and in the academic world, we have this thing called PASELC, in which it looks at not just the unhappy path in which you have a network partition between two replicas, but also what is the trade-off with regards to consistency and latency in the happy case when everything is operating normally. You can think of this as when you write to a single replica, what is the behavior of the other replicas? Do they serve reads right away with a very, very low latency at the risk of serving a stale read, or do they block and serve a strongly consistent read, but this has a negative impact on latency? Now, rather than forcing you into one hard extreme, many databases will only give you strong consistency or eventual consistency. And these are really, really hard extremes to choose from. Cosmos DB actually gives you a tunable consistency model in which we've made it very easy. We've defined some nice click stops in between so that you can actually make the right trade-off for your application. And once you've set this default, you can even take that another step further and override this consistency on a per request basis. So you get all of the awesome capabilities that I just mentioned as a fully managed service. We offer 4 nines of availability in terms of the most common SLA that people understand, which is the uptime SLA. And on top of this, we make sure that every time a write comes in, they're actually durably committed across a number of replicas. And we give you comprehensive SLAs. We're the first cloud service to then also financially back the characteristics around latency, consistency, and throughput. This is made possible by the fact that we run on a highly redundant architecture in which your data is actually distributed and replicated both within a region as well as across regions.
So I think this is very powerful. This means that you offer the same SLAs, and not only for performance and availability, but for every region and for every API that you offer.
Yes. And so what's really cool is we offer this SLA on the platform itself. And therefore, as we add additional APIs, you can take advantage of this and use the tools that you are familiar with. And rather than having to use our proprietary technology, you can feel comfortable with the tools that you already know and take advantage of a fully managed service on top.
Very cool.
So now, how about you tell me a little bit about Azure HDInsight?
Yes, so Azure HDInsight, as we know, is a managed open source analytics service for the enterprise cloud. Now, what I mean by managed open source analytics service is that we are a fully open source service. We're built on the Hortonworks data platform. We always keep up with the newest releases of the Hortonworks data platform. So I think 2.6 was announced last week. It was first on HDInsight. We have clusters up and running within minutes, and we take care of the installation, the hardware, getting the bits up and running, making sure that in the case of, let's say, an open source workload such as Kafka, your brokers are alive and up and running. And we give you an SLA on this to say that they will be up for 99.9% of the time. This really frees up enterprises from going and purchasing the hardware, the talent of installing, configuring these bits. Then really running these open source workloads in an enterprise production workload is a huge challenge for the enterprises. So you really drastically save on costs from a hardware perspective, from a talent perspective, from a manageability perspective as you move these workloads to the cloud. You also get the benefits of the cloud, such as elastic scale up and scale down. So if you have workloads that have really, really peak traffic, you can scale them up whenever the peak traffic comes in. Then you can scale these clusters down or even shut them down, really saving on costs as these workloads scale out to really big data, massive level. Additionally, we've also separated out compute and store, and this really gives the enterprises the flexibility to scale each independently, so you can drastically save on costs by not having to pay for an idle CPU or having to pay for idle disk storage while your CPU is really in effect.
Okay, so what does it mean to have a managed open source service for a customer?
So this means that when we install the bits, like I said, in the case of Kafka, we ensure that the brokers are up and running for 99.9% of the time. So we give an SLA on the end-to-end service, not just the underlying VM instances, right? So that means that from a customer perspective, I know that my cluster is going to be alive and up and running 99.9% of the time, not just the underlying VM instances, because then I can have peace of mind to say that the service is running, not just one node is running. We are also available in more than 25 regions worldwide. We are a service that is built on top of Azure, so we try to be in every region where Azure is. We launched in UK and US West recently, and we're also available in China, Europe, and US governmental clouds.
Awesome. So this sounds like it would go really well with a globally distributed database.
Yeah, and we'll walk through, how Cosmos DB and Azure HDInsight sort of intertwine together. But yes, the global availability story does become really nice for enterprises when they want to expand out to multiple clouds or even have a disaster recovery sort of architecture in place. Finally, since we're a service built on top of Azure, we have compliance baked in not only at the Azure level, but we also offer compliance for the open source bits such as HIPAA, SOC, PCI, ISO. Additionally, we have security built in from the ground up as well. This starts from data security, from encrypting the data at rest and then securing the traffic via HTTPS or SSL while the packets are in transit. Then we offer HDInsight workloads within a virtual network. This really provides for a perimeter level security where you can deploy 2 clusters within the same virtual network, and you can ensure that your traffic never leaves the virtual network that you have created, and then you can peer 2 virtual networks together, really ensuring that your packets do not go outside to the public internet. Finally, we have integration with Active Directory and authorization with technology such as Apache Ranger. So in the case of enterprises want to have some large clusters, they can then do some security groups to say that my large organization, some user groups only have access to this data and these folders or this row, or they can only read from certain topics and really have that fine-grained access as they expand their organizations out.
Oh, awesome. So how often are you asked about security?
So, this is asked in almost every single enterprise engagement that we have. Security is and compliance is a P0 requirement for almost all enterprise customers that we have. So this is a huge area of investment for HDInsight going forward, as well as we invest more in making authentication and authorization easier for customers as they onboard to large clusters. Finally, we realized that these are open source technologies, so there's a rich developer ecosystem that has been built around them. So there are open source tools, open source IDEs such as Eclipse, IntelliJ, Visual Studio, where developers are used to this ecosystem. So we offer a lot of tooling for these IDEs, where we provide a lot of plugins for doing some local testing or debugging. We also offer a rich data science experience via notebooks for Jupyter and Zeppelin, and we'll see a Jupyter notebook today, where you can see really the power of a data scientist just going to a notebook on a browser window and running everything from SQL queries to Scala code to doing some machine learning on this. So we offer a lot of support for that. We understand that this is a very rich client base that is there for data science, and we ensure that these notebooks are the best experience on HDInsight. Finally, we also come across a lot of shops where they're C# heavy, or they're very ingrained into the technologies that they have. So we try to meet them where they are. So in the case of some workloads on HDInsight, we've developed a technology known as SCP.NET, where we say that if you have a C# shop, that's okay. You can write your code in C# and then deploy that against a HDInsight Linux cluster, where we will translate the C# code into, in this case, let's say for Storm, into a Storm topology that runs on Java on a Linux cluster. So we offer support for developing in C# and then deploying your clusters out and topologies out in Linux on HDInsight.
How about debugging? What kind of support is there?
Yeah, so there's a first-class debugging experience as well. So, through Visual Studio or IntelliJ or Eclipse, the plugins themselves help you debug either locally or to the HDInsight cluster, and there's a very rich experience around this. We also offer tutorials, and we have a rich collateral that we have built out for these as well. And there's also an area of investment going forward. Finally, we understand that the open source community and the open source world for big data is very, very vast, and it is even growing with more and more ISVs coming into this space. And the ISVs really allow you to extend on the open source Hadoop ecosystem and the capabilities that they provide. So we understand this, and we understand that there are a lot of customers that have requests for these ISVs to do more with just their Hadoop and their Spark clusters. So we offer a first-class experience through the portal, and this screenshot shows how in 4 or 5 easy steps you can just have a cluster up and running. But if you just have one additional step of adding another application as an ISV, we take care of installing it, configuring it, the licensing. You just see that your application is up and running on top of an HDInsight cluster. So there's an example of some ISVs that we have onboarded as this experience, and we recently just announced H2O.ai as an ISV on HDInsight, and that is a really powerful machine learning ISV that has been in high demand and used out into the space today.
Oh, wow. So how do customers and users use HDInsight today?
Yeah, so that's a great question, Andrew. I had this slide where it shows a typical reference architecture for how enterprises architect their big data pipeline, and they really chop that up into 3 different areas. There's real-time analytics, interactive analytics, and batch analytics. And while I won't go through every single component on this slide, as you can see, open source workloads pop up everywhere, and you can achieve a robust enterprise big data, interactive real-time, and batch analytics pipeline by having these HDInsight technologies. So we have clusters that come up within 15 to 20 minutes. This can all be automated via a programmatic ARM template, and customers can have this robust pipeline up and running within minutes for what used to take them months or maybe even years to achieve at this scale. So this really provides the benefit of the cloud, the taking away of all the headache of managing, installing, and getting this pipeline up and running. And this is how customers are typically using it, and they just want to scale this out as their needs grow.
So let's take a quick look at how you can use Azure Cosmos DB and HDInsight together. And one of the most common scenarios that we see is performing real-time analytics, especially when you're talking about IoT. And typically what you see is, from a business standpoint, you have lots and lots of IoT devices, and each of these are constantly emitting telemetry. As a result, the amount of writes per second, the events per second coming in is very, very high. In one example, what you can do is you can actually send these off to something like IoT Hub or another message queue of your choice. And from there, you can take it into Azure HDInsight, where using Apache Storm, you can apply some business logic around that. You can do some pre-aggregation, as well as store the full fidelity raw events in Azure Cosmos DB. And where Azure Cosmos DB really fits in here really well is using this as a hot store, because it supports very, very heavy write ingestion. You can store the full high fidelity events themselves. And then you have a variety of mechanisms like change feeds, where you can actually then build automation on top of this, so that if you see an anomaly, not only can you report this back out to a dashboard and figure out what's going on, but in real time also use this to power, let's say, a set of logic to help mitigate, let's say, if it's a refrigeration unit. If you see temperatures start rising, you might want to automatically kick in additional refrigeration units to make sure that your goods don't spoil.
It's very cool, Andrew. I believe we have a very famous customer who's deployed this pipeline out in production today.
Yes. So we've worked with Toyota on building their Service Connect services for all of their new Lexus vehicles. And basically, they came up with a lot of the very similar challenges and came up with a very similar architecture to the one that we just presented. For their new Lexus vehicles, what happens is the moment a service engine light turns on, Toyota can actually completely figure out what is going on with the vehicle. They're generating an alert on their end as well as an alert on your end. And you can use this to also service vehicle health reports, and as well as help prepare their service centers so that they can say, hey, it looks like you have an issue with your vehicle, and don't worry, we actually know exactly what's going on. You can come into this service center, just please come in and we'll take it.
Very cool. So I believe when Toyota first started out doing just planes for Storm, and they were using, again, their storage architecture, and they found this to be a very painful thing to manage and get up and running. So they switched over to HDInsight as a managed service for Storm, and Azure Cosmos DB as a managed service for their storage layer for this really high throughput and low latency reads. And that really allowed them to focus on the applications themselves, and then get up and running within however long that was.
This greatly accelerated. It turns out that deploying and managing distributed systems is non-trivial, to say the least. And so what they were finding was they were spending an exorbitant amount of time just babysitting and making sure that their distributed systems are healthy. And because these are both fully managed platform as a service offerings, fully backed by SLAs, you even get the beauties of on-call support from world-class engineers at Microsoft, in which if something happens, we'll take care of it and we'll make sure everything stays online so that you have peace of mind for your service.
And this is very powerful, right? Like, this means that every Lexus that is bought today is powered by Azure HDInsight Storm and Azure Cosmos DB, and the data is flowing in, and Toyota can leverage that today for every single car that they're producing right now.
That is correct.
Very cool.
So as data also comes into Azure Cosmos DB, and you have all of this raw telemetry in it, recently we've also developed a Spark connector to allow you to perform data science over this data set. And so basically what you can do is you can use Azure Spark on HDInsight to provide scale-out computation and do really, really awesome, heavy analytical queries and aggregation on top of this cool cluster, and then have that connected to your data set being stored in Azure Cosmos DB as your scale-out database.
So today we'll show you a demo of this, but why this is really powerful, I believe, is because this allows Spark to query over an indexed database. So this means that Spark can look over the entire data set but not have to pull it all into memory. You can use Cosmos DB's APIs that really allow you to push down the where clause, and then you can just do the indexed lookups from there. So let's jump into a quick demo of this. So if I log into my portal today, as I can see, this is the Spark cluster that we have up and running. You can have this up and running within about 4 to 5 clicks and 15 minutes. But if we go to cluster dashboard here, we can see that we have the Jupyter notebook and the embodied dashboard for Spark. But if you click on the Jupyter notebook, these are the predefined notebooks that we have, and you can see that this is publicly documented. You can go try this out today. But if you just upload a Spark to Document DB connector notebook, then we have the Spark to Azure Cosmos DB connector, which uses the Document DB APIs. And I won't go too much into the architecture of this. There's a nice write-up on how this works. But at a very high level, the master node of the Spark will connect to the gateway node of Azure Cosmos DB. It will ask for a partition map, which will then be sent back to the master node of Spark. This partition map will be pushed down to the worker nodes of Spark. And then these worker nodes will use direct connect to connect to the partitions within Azure Cosmos DB, providing you really the parallelized high throughput that you need. So what we've done is we've taken a flight data set where we have a data set of flights and the delays, flight airports, and the delays that occur with each airport. So as you can see, the Spark, you can have within just 4 lines of code, you can point your Spark cluster to the endpoints for Cosmos DB. And here we've just put in our endpoints and our master keys, and this connects very well with Cosmos DB in just 4 lines of Scala code. But let's do some fun things with this. So if you were to just do a simple select of the flights originating from Seattle on this flight data set, you can just do regular SQL from here. And we see that there are about 23,000 flights originating from Seattle into this data set. But let's do something more interesting. And so Cosmos DB offers a SQL interface as well, but that is a little limited in the terms that it cannot do group bys. But if we marry it with Spark, now we can do group bys, where we want to say that, okay, what is the total delay group by destination? If we just run a simple query here, we see that because it's run on Cosmos DB and Spark, it comes back in a very, very fast manner for our interactive data scientists. And we can see, okay, these are the total delays for each given airport. But we can play with this a little bit more, but we'd really like to showcase the power of using Spark with Cosmos DB. So here, what we've done is, you can model this data set as a graph. And we can use graph frames from Apache Spark to do this. So we've modeled this database where the airports are the vertices for the graph, and the edges are the departure delays that go for this graph frame. So once we model it in this format, now we can do some interesting questions, such as which flights departing from Seattle are likely to have significant delays, and if you just sort these on the average delay, then we can see that Seattle to Philadelphia has an average delay of 55 minutes. So if you are maybe booking a flight, you might want to just run some quick fun queries on here to say that, okay, I might want to avoid this flight and then take a different one. We can also do interesting things such as knowing which is the most important airport, and if we sort the graph if we sort the edges the vertices of the graph on the degree, then it will tell us the number of connections going into each vertex. So if we just run this simple query here, we can see that Atlanta is the most important airport with about 100,000 connections flowing into it. So next comes Dallas-Fort Worth, and so on. So there are more interesting questions that we have populated in this notebook. There's a link to it. We encourage you to try this out on your own. But this is really to showcase how it's very easy to get up and running, and from here on out, this powerful tool is really anything that you can do from here. Finally, we have some getting started links today. There's getting started with Azure Cosmos DB. There's some edX courses, Channel 9 videos, and then we also have a link to your Spark and Cosmos DB tutorial that we showed today. If you have any feedback or questions, please feel free to reach out to us at askossnosql.com. at Microsoft.com. We will be more than happy to hear from you. Thank you.